One of the most important structures in programming is a for loop. A loop is basically a block of code that keeps repeating through the program so that you can run through some algorithm that you need to get through. It's also called a repetition structure. A simple example would be if we wanted to run through all of the numbers from 3 to 79 and sum them all up. If we wanted to do this line by line with sum equals sum plus j and keep changing the value of j, it would take 79 or 76 lines of code twice because you'd have to keep changing the value. But if we put it in a loop, we can just do it in a few lines of code and it will keep repeating. So what this does is we've set the value of j up here. J represents our counter, and then we have our sum here, which is going to hold all of the numbers added together. So the for loop starts with an initializing expression setting j equal to 3. As I said, j is your counter, so if you wanted the counter to start at 19, you would put j equals 19. So the first area, the initializer, is just where you want to set the value of your counter to begin with. The second value, j less than or equal to 79, is your sentinel. That is where you're going to keep track of how far you want that counter to go. It's also called a control expression. So as long as this value evaluates to true, then it's going to keep going. So in this case, it's less than or equal to 79. If we wanted to keep counting to 1,000, we'd make it 1,000. You do have to make sure that you write this condition so that the loop will eventually end. For example, if you set j equal to 3 and set this to continue until j was not equal to, as long as it was not equal to 2, well, j is never going to be 2 because 2 came before 3, so the loop would just keep going forever. So you want to be careful how you write that. And the third section of the for loop is the step expression, or the increment or decrementer. In this case, we want to step through one at a time, so I've put in j++, because as we already know, that just adds 1 to j. But it doesn't have to be that. It could be j minus minus, it could be j plus equals 4 if you wanted to step through by 4s. It could be j times equal 3 if you wanted to keep going in multiples of 3. It just depends on what you're doing in your loop and what you need that condition to be. So to recap, in this one it's going to start at 3. It's going to go until j is equal to 79, and then it's going to step through by 1s and go through and add this all up. And then at the end it's going to tell us what the total sum was. And we've also got this console write line in here to show us our progress as we're going through the loop. So as you can see, it goes all the way through, adding each time until we get to the final sum. Alright, so some extra things you need to know about using a for loop. First of all, you can use a break command. It's just like the break command in the switch. You just type break and a semicolon, and it will break out of the loop regardless of what this condition is. If you have it suddenly reach a condition that you want the loop to stop, put in the break and it will stop it, and it will just continue on down with whatever is below the loop. A second thing to know is the scope of the loop variable, or the counter. In the first example, we had declared j up here and then just used it down here. But you can also declare j inside the for loop syntax. The limitation to doing this is then if you try to use j outside of the loop, it's not going to know what j was because it was only local to this scope right here. So if you want to use j outside the loop, you won't want to declare it in the syntax of the loop. But if you don't need to, sometimes it makes it simpler. So now we've declared j up at the top, and it remembers what j is down at the bottom, so it can print that number. Another feature, you do put curly braces around the statements after the for loop in general, but just like with the if statement, you don't have to if you've only got one line of code in your for loop statements. So since this only has one line, I can take those curly braces off and it's going to know to do this just fine. But if I still wanted to do that console write line afterwards, This is now not going to be part of the loop because it's not inside curly braces, it's not in that first line. So if I run it, it's just going to give me the final number. It's not going to give me that running total like it did before. I would have to put this back inside curly braces. And now when I run it, it gives me the whole line of numbers. So remember, if you're not going to use curly braces, you can only have one line that you want to be part of your for loop. Everything else is going to be treated just as a regular part of the program. Now, I'd also mention that sometimes you might want to know after the loop finishes what the value of the counter is. So again, you can use that down below. I've plugged it in to say what the value of the loop is, or the value of the counter is. And in this case, it's telling me it's 80 because it went all the way up to 80. It saw that it was greater than 79 and the loop stopped. So the counter value was 80 and the final sum was 3,157. Another possibility with loops is to nest your loops. And what that means is you've got a for loop here and it does some statements, and then it has another for loop inside of it that's going to run on the inside. This might be useful if you're trying to make something happen for every day of every week of the year. You'd want the inner loop to be all of your days, and then your outer loop would be your weeks. Now this is a smaller example. You'll notice that both of these loops have different counter variables. If you use the same counter variable, they're not going to work right because you're going to be changing the variable down here and it's not going to be doing what it needs to up here. So in this case, j is starting at 0. It's going to go until it's less than, as long as it's less than 5, so until it's 4, and it's going to step by ones. The inner loop starts at 0 and goes until 7, and it also goes by 1. So in this case, when we run it, you'll see it does the outer loop, then it does the inner loop 7 times, then it does the outer loop, and it continues this until it's made it all the way through both loops. Now you'll notice it doesn't look back at this outer loop while it's still running on the inner loop, and that's the way they work. It's going to do everything in here before it ever steps out and comes back up here. So if you've got something that you need to run every time in this inner loop, you need to put it down here in the inner loop because it's not going to look back up here until it finishes all of this. Now, a final warning with loops, it's the same as with an if statement. If you put a semicolon at the end of your opening statement of your for loop, the program's not going to realize that's a problem. It's going to assume that you meant to declare a for loop and didn't put anything in it, and everything down below here is going to run just like it looks. So if I run this now, I get the outer loop once, and then I get the inner loop, and then it's done. Because it's still seeing this loop down here as a loop, but this one has had everything cut off from it. So remember not to put your semicolon at the end of your loop declaration, otherwise you're not going to get to finish your thought down here.